Good evening, good morning, good afternoon, boys and girls. Let's go with the lesson. So today we are going to learn about subnetting and IPv4. This is one of the most difficult topics that I have ever thought. Although for some people it's easy, for some people it's hard. What I recommend is to go over the lesson as many times as you need. If you have to go and watch the lesson 2 times and you find the concepts easy, you are good to go. But if you are stuck at some point or overwhelmed with the information, uh, keep viewing the information maybe 2 or 3 times, take a break, go grab a snack, get some coffee, get some tea, and then uh, watch another lesson, and then return to the lesson and watch it 2 more times. So let's do our best to teach you guys about networking and the subnetting stuff. Okay, so there are three classes of networks mainly. We have class A, class B, and class C. Let me just highlight that information for you. Improve the size here a little bit. And there you go, class A, class B, and class C. The subnet mask by default that we have for those classes are 255.0.0.0/8. That's a class A. And the ranges goes from 1.0.0.0 through 126.255.255.255. Then we have the class B. This one goes from 128.0.0.0 to 191.255.255.255. Class B has a default subnet mask of 255.255.0.0/16. It will be basically the same /8 or 255.0.0.0/16 or 255.255.0.0. And then we have 255.255.255.0 is /24. There you go. Those are all the main classes for IPv4. And you can ask, where Cesar, where did this come from? How this story started? Uh, it's back in the 90s where they have to allocate specific IP addresses in universities and colleges, and they didn't have this administration for the different IP addresses. And in order to avoid the exhaustion, um, how can we explain this? They need to mitigate and organize the IP addresses so we will have enough resources all the time and we will not run out of IPv4 addresses. So there comes some techniques that we will see later on during the course, like NAT. What is NAT? How does it work? We will learn that it's basically translating IPv4 addresses, private IPv4 addresses, into public IPv4 addresses. We will learn all these concepts later on during the course. Okay, now this class B range goes from 192.0.0.0 to 223.255.255.255. That is the range for those. There is an experimental IP addresses. Those are class D and class E. Class E are experimental. Those are used for research and scientific purposes mainly. And class D are multicast IP addresses. Now, there is something called decimal format, and it's basically the following. The ones are turned on and the zeros are turned off. Maybe I can look up another example so it's easier for us to understand that. So there you go. So this is what happened. If you have a 0, it means this is a 0, it means it is off. If you have a 1, it means it is on. And in this example that we are going to look up right now, let me just delete those drawings. If we are doing a conversion from decimal to binary or from binary to decimal, this is what happened. In order to complete this number, and we will see later on how to accomplish this specific number, you have to turn on some values. We are using 128 plus 32 plus 16 plus 2, and that is going to add up a total value of 178. If we do, if you do the sum right now, you will get the value of 178. So that's the way that we do the conversion. Some are turned off, of course, because we don't need them. In order to accomplish this specific number, we don't need them. So that's basically the first example. We will go into this deeper later on in this specific chapter, but I want to give you the idea or the understanding of how you are converting from decimal to binary and from binary to decimal. It is very important and essential in the networking career path. Okay, so let's return to our document, and this is where we are. We are turning all ones and the first octet on in order to get a /8 subnet mask. The rest of them are zeros. It means we are having at this specific moment a total of 8 bits turned on. Now, what happened with the 12? Can you imagine? This is what happened. You will be having 8 bits turned on plus 4, which is a total of 12 bits turned on. It means these bits are off, and all of these as well are off. We don't need them turned on at this specific moment. What happened with the 4/28? This one, we are having a total of 28 turned on, and the rest are off. And what happened in the last example? You are having everything turned on, and a total number of 32 bits are turned on. It means that we have reached the maximum value at this specific moment, the maximum value, because all bits are turned on. Okay, let me clear the drawing so we can continue moving forward with this topic. And maybe with more examples, you will learn better. Before moving forward, I want to um, I want you to have something clear, and it is the following. This /8 is equivalent to this decimal. This /12 is the equivalent to this decimal. This 28 is the equivalent to this one, and finally this 32 is the equivalent to this one. This is called decimal format, and this is called binary. So let's write that so you can have it in your heart. We have first decimal format, and if you're not taking notes, I recommend that you do it because this is very important. And this is binary format. Okay, amazing. That's what I want to show you. You can have a better understanding of subnetting, having these concepts down and understanding them. So let's move on. Let's move on. Let me go ahead and erase this board. Okay. And let's go ahead and delete this beautiful guy. Now, in the first example that we have here, this /8 is equivalent to 255.0.0.0. This /12 is equivalent to 255.240.0.0. And This is slash 28. So let me just validate this. Okay, this is the 12. Now, slash 28, what is it? 255.255.240. So this one goes with that one. This one goes with this one. Let me just do an arrow so we don't get lost. And this one goes with this one. What is missing there? Let me highlight it. Slash 32 is equivalent to 255.255.255.255. All the octets are 255. So let's count 255.255.255.255. It means four octets are turned on, and those are basically the 255s. All of them are 255s, the four octets. Now, how is this represented with the classes? So you have the following: class A, class B, and class C. Let me erase the first part, and maybe I can do another color so you can change. You can have another view of this. So if you have 255.0.0.0, remember it's 255.0.0.0. Remember to count. Those are three octets. At this moment, you have the first bits for network and the rest for host. Great. Now, what happened with class B? You have the in the class A, you have the first octet for network and third, the second, third, and fourth for host. On class B, that was class A, you have the first and the second octets for network and the third and fourth for host. On class C, you have 255, the 255, the 255, that's 0. It means the first three octets are for network, and the last octet is for host. Each one of these is called octets. Why is it called that way, or what do we call it that way? Because it's composed of 8 bits. Each octet is composed of 8 bits. So you have 8 bits here that are turned on, and then 8 bits here that are turned off, 8 bits here that are turned off, and finally 8 bits there that are turned off. What is the difference with the last one? On class C, you have 8 bits turned on, 8 bits here that are turned on, 8 bits here again that are turned on, and then 8 bits here that are turned off. That's basically what you need to know. So let's erase the board. Let's erase it. Let's move forward with this lesson. You can think it's not that important, but it is essential to know these concepts for the networking career path. Now, the following question comes up. What is supernetting? Um, Basically, to give you an easy understanding of what is supernetting is you are having a lot of different networks and summarize them. We will see an example about how to do this. Let's go ahead and look at the definition that we have there. When changing a number in the network part of an IP address, we will be in a different network from a previous address. So let's just stick with the concept that I was telling you about. Summarizing networks. Summarizing. Supernetting means we borrow some bits from the host part to add to the network. This allows us to have more networks than using the default subnet mask. For example, we can borrow some bits in the net octet to make the address 11.1.0.1 belong to the network from 11.0.0.1. Mm, let's look at this with an example so it will be easier to understand. how do we subnet? Do we have an example of supernetting? Probably you have it there. Hmm, I don't see it there. I don't see it much. I'm going to look for that right now. In order to start doing this subnetting and all that, I want to show you how to do this supernetting there. So let me just go there. Summarizing. There you go. So this is what happened. Let me increase this size a little bit. Okay, you have right now a total of 4 networks. And we're trying to summarize the networks into a single one. What is are what are we going to do and how are we going to complete this step? Okay, so this is what you do. There is a process of changing all of them to decimal format and find similarities. And once you do that, you will get this network 192.168.0.0/22. That is the route summarization that you are doing. I'm trying to see if I find an example of this one because I don't have like the process here, but I'm going to do it with a calculator. So maybe I can show you the process and you can understand it better. So let's go for it. Let's go. Supernetting. I have a calculator about this. And I will share this one with you as well. Supernetting. There you go. Okay. So we're going to add these IP addresses in this calculator. Now remember, and I will share this with you later, that you can have spaces there. There you go. Now we need to validate the different IP addresses, 1, 2, and 3. So let's add that. We have 1, we have 2, and we have 3. Let's calculate it, and there you go. Now, upon doing the conversion of decimal to binary, there are some similarities there. And you will see the following. All of them are pretty much the same. 192 and 168, those are the same. And the first 2 octets. What happened on the last 2? You have 0 and 0, meaning that specific network will be, it will be 192 and 168 at 0 at 0. Now, what we need to figure out is where does the 22nd comes from? That's what we need to figure out. Because I don't have it there. Now, you did the calculation and everything, but I know when you are converting from the mask, specific mask, and you are doing this conversion, you get a different mask. So that's what I'm trying to figure out right now. Where does the 22nd comes from? Let's go ahead and ask our friend because we want to be clear. Where does that /22 comes from? I know it's because of the mask and it is a conversion, but we want to be sure how do we get it. Now, we were doing the conversion there and let's see. If you want to aggregate 4 subnets into a single block, you must find a common prefix in binary, which is 22nd. So we are using 10 bits, 10 bits for the similarities, and that's what we have here. Those are similar. All of them are similar. How many values do we have there with the similarities? You have 8 plus 8 plus 8. Those are 16. Let me see. It's actually more than 8. 16 plus. Okay, let me do the calculation. Let me just look for the calculator there. So 22nd, 22 minus 16 is 4. So we are still missing 4 there. Okay, so we will be counting a total of um 22, 22 in order to get that specific mask. Now I want to go back to the ChatGPT conversion to fully understand this. When we are doing this conversion, the mask is 22. And I want to understand this. Okay, in order to get those addresses, we need 10 bits. And okay, let me see these 10 bits there. Those are 8, is actually 8 plus 8, those are 16. Okay, we have 17, 18, 19, 20, 21, 22. Okay, there you go. So the 22 are there, but now this is what happened. You are moving and counting from right to left to get that 10 value, those 10 bits in order to do those conversions. So right now we have 8 plus 2 is actually 10. That's where we get the 10 bits that we're borrowing in order to complete the correct subnet mask. Okay, so let me go back to the example so you can fully understand what we're doing here. Upon the conversion or during the similarities and doing this conversion from decimal value to binary, we will have some similarities. And right here, you will see the similarities. Now, you are borrowing a total of 10 bits, which is actually 8 bits plus 2, meaning that the subnet mask will be 8 plus 8 plus 6, a total of 22. That's where the slash 22 comes from. And we finally figure out the mystery. This is a little bit tough to understand at the beginning, but with practice, it will be easier to understand. Let's see if we can find another example. This one, slash 16. We are doing the same conversion. You are basically doing 8 is the current mask. How do we get a total of 14 here? Okay, right now, you need 4 to the power of 4 in order to have these 4 subnets. Those are these specific 4 bits. Now you're counting the other part. You're counting the 255 that and the rest. Those are 8 bits. 9, 10, 11, 12, 13, 14. There you go. There is the 14 value for the specific mask of the summarization that we are doing. Now I'm going to share all this material with you so you can practice and do the following. If you can find a notebook and do this by hand and do the conversions and do the decimal value to binary, it will be helpful for CCNA certifications, for your exam, and for real life. Okay, let's continue moving forward with the first tutorial that we were working on before. And this is what happened. I want to make sure I am recording. Everything seems correctly here. Give me just a moment. Mhm. 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 Okay. All right, let's continue moving forward with this tutorial. We want to understand now what do they mean with subnetting and why is it necessary? Okay, so do you remember in the subnet mask, a bit value represents a one in the network portion, in the network part, while a zero represents the host part? Well, in this one, you can see all of these bits are host, host, and all of these are network. We have a total of 24 bits for the host portion and 8 bits for the network portion. The decimal value that we have here is a network of 11.0.0.1. This is the default mask. Now, you can see clearly that we are going to borrow a total of 8 bits, and our subnet mask will be like this. If we're doing a borrowing only a total of 8 bits, this is basically what we are doing in the first example. 8 bits in the network, 24 bits in the host portion. Now let's see what happened with the class. This is a class A. Now what happened with class B? With class B, you are borrowing 16 bits for the network portion and 16 bits for the host portion. That is a class B. Same network, class B. And finally, we don't have it here, but if we were doing a class C, it will be the following way. You will have the same network, 11.0.0.1, and then it will be the same value, and then you will have the one, all of these in once, the first three octets. Let me just erase this one. So you will have the following. You will have, let me see if I can do a blue color here. You will have a one, another one, and so on, all of these ones, and this will be a total of 24. So instead of 24 for hosts, we will have this 24 for network. So it will be 24 network, the network portion, and a total of only 8. Let me just write that. Only 8 for the host portion. So let's write that. You will have 8 bits for host. And those are the following value. 255.255.255.0. There you go. That will be the final option when doing subnetting, which is class C, a class C. Okay, great. Let's go ahead and erase everything here. Let me just erase the drawings. Let me erase this guy. Maybe I can find more examples so it will be easier. Calculate how many networks and hosts per network. This is the first part. So 2 to the power of n will give us the current different subnets that we need. And maybe we can look up some examples. Look at some examples here. Okay, there you go, the first one. Your company has been assigned a network of 4.4, 4.0.0.0. How many subnets and hosts per subnet you can create with a subnet mask of 255.255.255.0. Okay, you see the solution there. First of all, you have to specify which class this network belongs to. According to what we have learned, which class do you think this one belongs to? According to the table, it belongs to class A. Simply arrange from 1 to 126. And its default subnet is 255.0.0.0. Therefore, if you use a subnet mask of 255.255.255.0, it means we borrow 16 bits. If we are doing the conversion, the default value for this one is a class A, and you are using a class C for doing the subnets. Okay, so now let's use our formula to find the answer. The number of the newly created is 2 to the power of 16. And where those 16s came from? 16 from these. These two octets is actually 8 plus 8, a total of 16. Will give us a total of 65,536. With 16 is borrowed bit. The number of hosts per subnet is 2 to the power of 8 minus 2. It's a total of 254. Now, where do we get the number 8? That's the big question. With 8 bits, is the bit 0 left? Okay, those bits for the host portion are these that we have there. There you have the host portion. Remember, the class C is actually network, 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 and hosts. Those are the 8 bits. So 2 to the power of 8 minus 2 will give us a total of 254 hosts per subnet. Now it looks clear. Let's go ahead and erase those drawings and continue moving forward. Maybe we can look at another example and finally understand this better. Okay, solution. Okay, this is the next problem. Let's go ahead and read. Let me highlight it. Your company has been assigned a network of 130.0.0.0. How many subnets and hosts per subnet you can create with a subnet mask of 255.255.128.0. The solution is that this one is a class B with a default mask of 255.255.0.0. But it is strange. If you look at the value for the mask, it's different. Let's write the values from decimal to binary to figure this one out. First, we convert the subnet mask, and then we do the conversion for the default mask, which is a class B. Now, we are doing this conversion, and the first thing that we get is that we are only using a 1. So 2 to the power of 1 will give us a total of newly created subnets. 2 to the power of 1 is 2, with 1 is borrowed bits. So you have a total of 2 subnets. And now, how many hosts per subnet do we get? On this one, if we count all of them, 8, 9, 10, 11, 12, 13, 14, 15. It will be a total of 15. To the power of 15 minus 2. We subtract 2. We get 32,766, which is for this specific subnet where we're doing the subnetting. So we will be having a total of 32,766 hosts per subnet for those specific 2 networks or subnets. We have successfully completed 2 to different scenarios with subnetting, and it wasn't that difficult, was it? What do you think? It's practice. Remember to use your pencil or pen in a notebook and write these examples and practice. Let's look at another example, exercise 3. Your company has just been assigned your company has just been assigned the network 198.23.16.0/28. How many subnets and hosts per subnet you can create with a subnet mask of 255.255.255.252? Okay, in this exercise, we have the following. And remember, please try to solve it yourself before reading the solution. If you can stop the video, go ahead and do it yourself, and then look at the solution. It will be a more suitable learning experience. Now, first thing you do is the conversion. /28 is actually decimal value. We need to do the conversion to decimal value. You will get a new subnet mask of 255.255.255.254, 240, 240. That is the /28. When you are doing the conversion of this one, you have this decimal value and then this value for this binary value. Correction, this is the binary and this is the decimal value for /28. Now, same thing applies. And let me just change colors. Maybe use a pink. This one is the decimal value. This one is the binary value. And this one is /30. Now, in this case, you borrow 2 bits. And how do you know? Because you're using a /30. If you look at this, you're doing a /30 for subnet, the subnet mask, doing subnetworks. 2 to the power of 2 is 4. So you will be having a total of 4 new subnets. Now, you are going to count the other section, the 0. So let me just erase this a little bit real quick. We are missing those zeros. Maybe use a green color there. Those 2 zeros is the same, 2 to the power of 2. If you're doing 2 to the power of 2 minus 2, just subtract 2. You will get 2. It means the number of hosts per subnet are 2. There you go. Let me just do that. You have 2 hosts per subnets. And those hosts per subnets are the computers that you will have available in the network. It means you will have a total of 4 networks, and each network you will have a computer or an end device per se. In this exercise, I want you to go deeper into subnets created. We learned there are 4 created subnets, but what are they? To find out, you should write all things in binary. You have the don't care bit, and you have the subnetted bit. Okay, so is this the same network? Yes, this is the same network that we were working along. You are doing the conversion. This one, we don't really care, and we only care about the last. You are doing a /30, the plan subnet mask, and the assign /28 subnet mask. You are doing 2 bits for the host portion and 30 bits for the network portion. Because 2 subnet masks /30 and /28 only affect the 4th octet, so we don't care about the first 3 octets. In the 4th octet, we are allowed to change 2 bits in the green box of the IP address to create a new subnet. So there are 4 values we can use: 0, 0, 0, 1, 1, 0, and 1, 1. After changing, we convert them back to decimal number. We get 4 subnets. First subnet is 198.123.16.0/30, and the second subnet we get 198.23.16.4/30. Now the other one will be 198.123.16.8/30, and finally you will get 192 and 123.16.12/30 for the fourth octet. Those are the total of 4 networks that we were doing this subnetting for network. And you are counting, and you will see about an easier way in a moment. If you start doing, let me see, 0, 4, 8, and 12. You see, those are 4 by 4. We are doing increments of 4, 4, then plus 4, plus 4, and so on. The first network will be all the available IP addresses from 0 through 4. So it will be, for example, 192, the 198, the 23, the 16, that 1. These will have 2 available IP addresses. Now I want to show you how to do this with a calculator. Maybe I can show you. I'll do my best. Let me see if I can give you an example. So you have 188.23.16.0/28, and we are moving this to /30. And I want to go with a calculator and show you guys how to do it. Let me just go to this one calculator. They don't really teach you this in CCNA courses because sometimes they think this like cheating, but it's actually a specific tool for real life scenarios where you are in an urgency of doing this. And it's important for you to fully understand if you have to do it, how to do it. So let me go ahead and copy this specific address. Let me just erase it. 182.23.16.0. 198.23.16.0. And we have 30. We're trying to move to 28. Oh, did I got it right? It's actually 28 to 30. So we are moving from 28 to 30. Let's calculate. And there you go. Those are the IP addresses that you can assign to a specific host. Those are the ranges. In less than 1 or 2 minutes, you have this updating for this. I will share this website with you so you can have it available. And remember, if you can do this by hand, use a pencil, use a pen, use your notebook, and practice doing the conversions from decimal to binary. It will be useful for real life, for CCNA certifications, and for different exams or even job interviews. So don't rely only in the calculator because the calculator is amazing, but when you work in this, you have to understand by heart how to complete these scenarios, both with calculator, with easy subnetting, and with the old way of subnetting that we have learning today. So let's continue and let me see if we can go over to the quick and easy way. It's called the magic number. And this is what happened. You have the different versions of subnets /28, /192. So those are masked. It's actually not slash, it's actually the decimal and the binary. You have the decimal and the binary. And now, in order to get the subnet, you have to do the following. You have to do the following. I'm going to see if we can find an example. Oh, this one that we were doing. The one that we were doing with the calculator, this one. How do we do this one with the magic number, or these increments. You have to take the number of 256 and subtract 2 to the power of 2 will give us a total of 4 networks. So you have to subtract 4. 4. This will be equal to 252. And this is what happened. It will be doing jumps or increments of 4. So if you have the first network like this, 198.23.16.0/30, the next one will be 416.4. The next one will be 16.8. The next one will be 16.12. Do you see the pattern here? Do you see it is incremented? 4, we have 0, then 4, then 8, then 12. That is the magic number. In seconds, you have to and completed the subnetting of this. Now, the subnet mask will be 255.224.0.0. If you are doing the conversion of this one, /29, you will get 255.255.255.248. 248. Now, this is a different one because the one we were doing was from 28 to 30. So this is a different one. But maybe we can go over this example again. The one that we were doing the calculator and the conversion. You have to get to the 30. And you know 252 belongs to the fourth octet. And you subtract 256 minus 252 is equal to 4. And you're doing the conversion. You're doing the first network. The second network, you only add 4 there. The third, you are 4 plus 4 is 8. And the last one is 12. So it will be 192, the 23, the 16, the 12. That will be the last network. Everything between those networks are the valid IP addresses for end devices. Now remember, you have only 2, and we have looked at this example before. 2 hosts per network, and those are 4 subnets and 2 hosts per network. Okay, these specific IP addresses or these specific values, you have to memorize them for the CCNA exam because those are very useful when you're doing these conversions and subnets. I'm going to show you a table that it is actually easy. This is another conversion, another example of the easy way. But I want to show you something else before we close this chapter. I want to show you the subnetting table. Subnetting table. Images. This one. Okay, let's visit it. Okay, there you go. I want to share this with you. I'm going to save it. Share with you. It's actually subnetting dash table dash JPEG. Maybe I can just save it there. There you go. So I will share this with you, and this is what you will be seeing there. Let me just see, go to downloads. Maybe I can open it here. What is going on? No, it's actually not working. Let me just go back to the previous page. Let me go back there and see if I can change it. Or maybe I can go to the specific lesson 4. Let me just save it like that, and I will change the name in a moment. In lesson 4, subnetting table. Let me just delete it because I want to show you why this is so important. When you're doing subnetting in seconds or minutes, and you're running against the clock, it is essential to fully understand this table and memorize some of the values. And of course, I will share this with you. So if you have a total of 256 hosts, it's slash 24, and it's 255.255.255.0. If you want to get a total of what is it? 16 hosts is 255.255.240 slash 28. If you want to get only a total of 4 hosts per network, 255.255.255.252, and it's a slash 30. Now, using this plus the magic number that we have got over it is essential. You can do magic number, you can do decimal to binary and binary to decimal. Either way, you have to learn all these concepts and keep practicing. Also, I will share with you a book so you can practice all of these by yourself. It's related to subnetting, and this is the book. It has the answers and everything, but I want you to have some practice with the subnetting, and doing these book exercises will be helpful for you. Now, I'm not sure if I can get the student version. I'm going to look it up right now to see if I can find it. Let me just stop the recording. Okay. I got it. I got it. So I want you to go over the student version and do your best to answer these exercises and practice as much as you can during this week. Um, if you get tired and you don't find the answer, go over the instructor book with the answers and compare your answers with the instructor and do that comparison. It will be a great exercise to become familiar with subnetting and become an expert on this topic. Okay, so we have done pretty much everything for today, doing the tedious subnetting process, doing the calculator, doing a little bit of supernetting, doing the subnetting basic stuff. And that's pretty much what we have for today's lesson. That's pretty much everything. We have covered pretty much everything. You can look for YouTube videos on doing more subnetting for summarization exercises. But I think pretty much with this book, you will have a lot of work and practice and material to go over it and break your head a little bit in order to become an expert in subnetting. You have you will have both. You will have the instructor manual for IPv4 and the student manual for IPv4. Okay, so pretty much this is what we have covered today. We have learned a little bit about the subnetting in the tedious way and subnetting in the easier way with the magic number. We have learned about the classes. You have learned also that in order for having IP addresses available, companies use private IP addresses and convert them into public IP addresses with the internet service providers. And that is a way to mitigate the IP addresses and organize them better and avoid um, the exhaustion of IP addresses because we always need the IP addresses. We will learn about IPv6 addresses and why they are used for and all that later on in the next chapter, but you have pretty much grasped the uh, fundamentals and the essential knowledge in order to move forward with your networking career. And this is a very important part of your networking path. Learning subnetting is like learning to play the guitar or learning to do shopping. You have to do it every day, practice as much as possible. Remember, practice makes perfect. So, we have pretty much covered today's lesson. It's been a pleasure working with you. Remember that some of the topics are a little bit confusing and they take practice. So, put, look for your notebook, look for your pencil and pen, your eraser. Practice as much as possible doing conversions from decimal to binary, from binary to decimal. And if you need to watch this lesson 20 times, do it. Do it because it's essential for you to move forward in your networking career path and understanding these concepts. Until next time, my name is Cesar. Take care. It's been a pleasure and goodbye, boys and girls. I'll see you at the climb of success.